Welcome. So we're going to be writing the equations for these graphs in terms of both sine and cosine. Any graph that can be written in terms of one can be written in terms of the other because the two functions are just shifts, horizontal shifts of one another. Whether the graph is written, whether the equation is written in terms of sine or whether it is written in terms of cosine, some things will remain the same. Amplitude will not change, period will not change, and vertical shift will not change. Those three things will be the same whether the graph is written in terms of sine or in terms of cosine. All right, we're going to start off with most of these are easier to write in terms of sine, not because sine is the easier graph, but just because the equation in sine doesn't have a phase shift. It is starting on the y-axis. So in terms of where the graph starts on the y-axis, it is a sine wave. But if we don't start it on the y-axis, we also have at least one period of cosine for these graphs as well. So we're just going to start off, well, the first two things, amplitude and period, won't matter whether we write this in terms of sine or cosine, but we are going to start off with identifying a period of cosine. So this represents one period of cosine. Right? So cosine, if there's no reflection, cosine starts off at the maximum, crosses the x-axis, has its minimum. Actually, let's go ahead and write that. Maximum, x-intercept, or midline if it's been shifted up. Minimum, and then back to the maximum, right? That is one period of cosine, and that period begins right here at x equals 2, right? It begins there because that's where the maximum, that's where where we have the maximum, right? That's the first point where we have a maximum, which is where cosine starts, right? So what you have what I highlighted there represents one period of cosine. So the period would start there, and it would end there. So this is let me move that minimum. The minimum is referring to the point. This is one period. Right? That represents one period. This represents the amplitude. We're going to calculate this out as well as identify it from the graph. All right. For amplitude, amplitude is the max minus the min divided by 2. So that would be 4 minus negative 4 divided by 2 is 8 divided by 2, or 4. All right, so we can either look and see that from the midline, so right here is the midline, the middle of the graph. From the midline to the maximum, that is indeed 4, or we can calculate it out as maximum minus minimum divided by 2. The period, though, we will just identify right from the graph. So the period, and we could calculate it out too a little bit. The period ends at 10, and the period that we have outlined there begins at 2. So the period here is 8. All right, this is a real-world graph, and it's in, I don't know if it's in terms of time. Looks like it's in terms of time, so how much the water displaces over time. So we have the length of the period, and we have the amplitude. The phase shift is where if the graph does not begin at the y-axis, the phase shift is where does the graph begin. So for one period of this graph, you can see that the period starts at 2 and ends at 10. Right? This right here is the phase shift. How long does it take from the y-axis for the graph to begin? All right, so this graph is shifted to the right. Right? Our graph doesn't begin at x equals 0. It begins at x equals 2. Right? So now for the this particular graph does not have a vertical shift. The midline is right at the x-axis. So in terms of writing the equation of this as a cosine graph, we have the format y equals a sine b and then x minus c. So the a is the amplitude, which we know because it's 4. B we have to solve for. So for B, we're going to use the period, right? So the period is, if we add in the equation, the period is calculated by period equals 2 pi divided by b. Right? So we can replace the period with the length of the period, cross multiply, and solve for b. So that is how we would solve for b, using the period. So the period is 8. So we have 8 over 1 equals 2 pi over b. We will cross multiply. So 8b equals 2 pi, and then divide both sides by 8 to solve for b. So b is 2 pi eighths, which we could reduce. They're both the 2 and the 8 are divisible by 2, so that would be pi fourths. So the b in the equation is pi fourths. And then the last part is the phase shift. So if the phase shift is to the right, it's positive. If it's to the left, it's negative. There is already a minus sign, a subtraction sign in the equation. So notice it's x minus c. So it is going to be a minus if the phase shift is positive. It's going to be a plus because we'll have minus a negative if the phase shift is negative. This one is, the phase shift is 2. Our graph shifts 2 to the right. So the equation for our graph as a cosine graph we wrote a lot of them in terms of sine. I accidentally wrote sine there instead of cosine, even though we're writing this in terms of cosine. All right, so the equation, actually, I'm going to put it up above the, so I don't have too much room. I'll put it right above. So the equation I don't think I used my space well. We're going to replace the A, the B, and the C. Once you have all those values solved for, that's all you have to do is replace it. So this is going to be y equals 4 cosine pi fourths, and then in parentheses, x minus 2. All right, you do not need to distribute. You can leave it with the parentheses. It does make it easier to see each of the parts. What's the value of b to find the period? What is the phase shift? So it is easier to find things if you don't distribute it. So there's our equation in terms of cosine. So the equation as a cosine graph is right there. Y equals 4 cosine pi force x minus 2. What if we write it in terms of sine? Right? Well, sine starts at the midline, right? So this is 1 period of sine. Right? So that is, so the red is 1 period of cosine. The green is 1 period of sine. Where am I going to put it? So 1 period sine, right? What stays the same? The amplitude stays the same, right? The amplitude here is still 4, right? We have the exact same amplitude, same distance from the midline to the maximum, right? So the amplitude is still 4. The period stays the same, right? If you notice that period is now, right, the period ends at 8, and we're starting at 0. It's still 8. We have the exact same period as before, right? Whether it's sine or cosine, it takes the same distance to go through the cycle, right? It's one loop around the unit circle, right? And it doesn't matter. And then changing b, of course, changes how long it takes, but it changes it just the same for sine as it does for cosine. The one thing that is different is the phase shift. Notice that the graph now starts on the y-axis. So there is no phase shift. Other than that, the equation is exactly the same for sine as it is cosine. The equation of this graph is y equals 4 sine pi force x. And that is the only thing that's ever going to be different between if we're writing an equation for a graph in terms of sine versus cosine. One of them is going to have a phase shift, and the other one might not have a phase shift. So the only thing that differs is the phase shift, because they start at a different spot. So that's it. That's everything for our graph here. All right, so we've written the equation. We're going to do the same thing one more time. Well, at least one more time. Oops. I wanted to see how long the video was so far, and I moved the recording box, and I couldn't hit the arrow to turn the page. And I'm going to try to write smaller, but this is taking up a lot of space, as you can see. I think actually if I do that, that gives me a little bit more space, especially if I do this. Oops. Sorry, I hit the extend the page. There, I have a little bit more space. All right, so the amplitude, all right, amplitude is max minus min. All right, here is the max, here is the min, and then divided by 2. So that would be 1 minus a negative 1 divided by 2, which is 2 divided by 2, or 1. All right, and we can see that from our graph this represents the amplitude. So the amplitude is 1. We're going to write this first in terms of cosine. Cosine starts at the max, goes through the intercept to the min, intercept, and back to the max. All right. So every 2 spaces is pi halves. So you can see that this is pi over here. This would be pi halves, and that's where the graph, the period is starting. And 2 more spaces to the right, this is 5 pi halves. I'll just label this. So pi halves, and 2 more spaces is pi, and 2 more spaces is 3 pi halves, and 2 more spaces is 2 pi, and then this would be 5 pi halves, 2.5. Right, so this is the length of the period. When there's a shift, it's easier to calculate period by subtracting the end of the period minus the beginning of the period. So the period is 5 pi halves minus pi halves, which is 4 pi halves, which is 2 pi. All right, so remember that 2 pi is the usual length of a period of sine or cosine. So b equals 1 when the period is 2 pi. We didn't do anything, right, to change. We didn't change the period at all. It's the standard period, as opposed to back here, where the graph, boy, there's a lot of writing here, huh? Here, where the graph had a period of 10 minus 2. It ended at 10. It's not even in terms of pi, right? It's in terms of numbers to match our real world situation here. So here, b is not 1. We have to solve for it. If the period is 2 pi, you don't have to solve for b. b is going to be 1, because only 2 pi divided by 1 is still going to be 2 pi. So we have b, we have the amplitude, we just need the phase shift. All right, so our graph is starting here. All right, this represents, at pi halves, this represents, I'm going to put PS for phase shift. I don't have that much space. So that represents the phase shift. All right, so the phase shift is pi halves. The equation in terms of cosine is going to be y equals a cosine b and then x minus c. A is 1, right? That was the amplitude. We found that. B is also 1. The only thing that's not 1 is c. C is pi halves, the phase shift. So we can write the equation. We don't have to plug in 1 for A and B. So y equals cosine x minus pi halves. What's this equation in terms of sine? I'll outline it in green. So the amplitude stays the same. The period stays the same. Actually, it's easy to see. There's the end of the period, right? So here's one period of sine. It's easy to see that that is 2 pi, right? And there is no phase shift, right? So for the sine graph, A is still going to be 1, B is still going to be 1, and C is 0 because there is no phase shift. It's starting right at the y-axis. So, and specifically at the origin. So what's the equation of the sine graph? So same format, y, except it's sine instead of cosine. Y equals A sine bx minus c. All right, well, a is 1. A is 1. Actually, I wrote it over here. I won't write it again. A is 1, B is 1, and C is 0. All right, we don't need to plug in 1 for A. We don't need to plug in 1 for B, and we don't need to plug in 0 for C. This is y equals sine x. All right, no change in amplitude, no change in the period, and no change, no phase shift. So this was a graph we had done earlier when we were writing equations for sine. Now we're just adding that information in so that we can compare what's the graph of cosine and what's the graph of sine for the same graph, because every single one of these can be written in terms of both because they are just phase shifts of one another. Right? They go through the exact same points, they just don't go through it at the same time. Right? And they both take just as long to go through their sequence of points. I think I've got like 5, somewhere between 3 and 5. I've got 1 here, there's 3, 4, and is that it? 5? I thought I had 5. Let's see if I'm right. Yep. All right, so we're going to write the last 3. And we'll only solve for B if the period is not 2 pi. Some of these they are. I'll just note it. All right, so amplitude. All right, this is the mass. So actually, let's outline. Here is, I hope you can see that okay on the blue. Here, let me make that another color. All right, orange it is. All right, so this is one period of the graph. This represents the amplitude from the max to the midway point. We can see it on the graph. We'll also calculate it out. Here's the min. All right, so the amplitude is 1/2, 0.5 or 1/2, minus a negative 1/2 divided by 2. That's going to be 1/2 plus 1/2 is 1. 1 divided by 2. It's just 1/2. And you can see that on the graph. The period since we have a phase shift, we'll subtract the end of the period minus the beginning. So this is pi halves. This is 3 pi halves. Oops. And this is 5 pi halves, and you probably realize these are the same values as we had before. So same period. So 5 pi halves minus pi halves is 4 pi halves, which is 2 pi. So since the period is 2 pi, B is 1. All right, so we don't have to solve that one out. And then the phase shift. This graph starts at pi halves. Actually, it's very similar to the last graph, except for the amplitude. So the phase shift is pi halves. You can see it right here. There is the phase shift. So for the cosine graph, this is, the format is y equals a cosine bx minus c. A is 1/2. Sorry, I was looking for A is 1/2. B is 1, so we don't need that one. And C is pi halves. So the equation is y equals 1/2 cosine, oops, well, I don't know if you saw that, but I'm going to have to take stuff off again, x minus pi halves. All right, and so there is the equation for cosine. What's the equation as a sine graph? All right, so one period, I need another color to write in. I don't want it to be too dark. So how about, I don't know, I think you can see that color. So here is, oops, here is one period of sine. So notice that it goes from here to here, one period. It's the exact same length period, right? Because that doesn't change. Only they will take the same equation written in terms of sine or cosine will have the same amplitude in the same period and the same vertical shift. In this case, none. The only thing that ever changes is the the phase shift, because they are phase shifts of one another between sine and cosine. So A is also 1/2. B is 1, and C is 0, because we can see it's starting on the y-axis. So the grayish one here is sine. So this is the sine curve, one period of sine. And the orangey one here, which goes from here to here, is one period of cosine. Right, so we'll go ahead and write the equation. Y equals A sine B x minus C. The A is 1/2, so we have 1/2 sine. The B is 1, so we don't need that. And then the C is 0, so this is just going to be y equals 1/2 sine x. The only thing there is for the sine graph is an amplitude change. For the cosine graph, there's also a phase shift. Easy peasy. Right? All right, here's our next one. This one finally has a period change. This would be one period of cosine. Actually, I'll label this time when I write period. I'm going to put cosine, because that's one. That is one. Here we're just highlighting one period of cosine. I think we are okay just filling in that the amplitude for this graph is 1. Here is the amplitude. Right, the period, let's calculate that out. So each one, this time, each line, I believe, is 1/4. Yeah, so this would be pi halves. So every 2 is pi halves, so every 1 is pi fourths. So that's pi fourths, pi halves, and 3 pi fourths, and then we have pi, and then 5 pi fourths, and then 3 pi halves, 7 pi fourths, and 2 pi. All right, so you can see that the phase shift, the graph is starting at pi fourths. So this right here represents the phase shift. Let's put PS. So phase shift, oh, we didn't talk about the period. All right, well, I guess I'll start with the phase shift. The phase shift is pi fourths. Let's calculate out the period now. So the period the graph, the period ends at 5 pi fourths. Right, so the period is 5 pi fourths, and it begins at pi fourths, so that's going to be 4 pi fourths, or just pi. We will solve for b. Right, number period equals 2 pi divided by b. That's how it's calculated. In this case, our period is pi, equals 2 pi divided by b. We'll cross multiply, so we have pi b equals 2 pi. Divide both sides by pi to solve for b, and b is 2. So we're going to write the equation for the graph now. I guess I'll put it here. Y equals a cosine b x minus c, or b, the b is 2, a is up above, it's 1, and the phase shift, the c, is pi fourths. So we'll just plug in the values. Y equals, we don't need the 1, y equals cosine 2 times x minus pi fourths. And there's the equation. The sine graph is just starts here, right? So here is one period of sine. Notice the period is still, so one period sine. So maybe I should make this here another color so it stands out a little bit. All right, so this phase shift is for the cosine graph. Notice that the sine graph does not have a phase shift. It is starting at the y-axis. So the A is still going to be 1. The B is still going to be 2. But the C, the phase shift, is 0, because that is starting right at the y-axis. So this would the equation would be y equals a sine b x minus c. We don't need the a of 1 or the c of 0. So this is just the equation y equals sine 2x. Right, so a's and b's of 1, you don't need to write a coefficient of 1 in, and c of 0 does not need to be written in. So the same graph could be represented with y equals sine 2x or y equals cosine 2 times x minus pi fourths, right? Because you can see how we can have one period of sine in green and one period of cosine in red. And they're just phase shifts of one another. Right, this is the last one. Looks like there's an amplitude change, but there isn't. All right, let's highlight one period of cosine. This is the only period we can see. All right, so this is one period of cosine. The amplitude is indeed 1. A little stretched out on this graph because of the scale, but the amplitude is 1. Right, so amplitude equals 1. The period, so it starts, every one of these is pi halves. So this is pi halves 0. This is negative pi halves. We're on the negative side. Right, and this would be 3 pi halves. All right, so the period is it ends at 3 pi halves, so 3 pi halves, and it began at negative pi halves. Right, so 3 pi halves, that'd be plus pi halves. That's 4 pi halves, and that's just 2 pi. Right, so it's more apparent with the sine graph than it is the cosine graph, but the period is 2 pi. That means that b is 1. Let's go ahead and just look real quickly at the sine graph. So the sine graph starts here, goes down instead of up, and ends here. So notice that the cosine graph is just going like it normally does, right? Starts off at the max and the intercept min, and then intercept and back to the max. But the sine graph has a reflection. So the cosine graph, no reflection. I'll put it here, no reflection, because it starts at max. Let me move this down. All right, and the sine graph has a reflection. Right, because notice it's going down instead of up, right? So here A is going to be a -1, whereas for the cosine graph, A is just 1. So the last thing is the phase shift. All right, this here is our phase shift. And notice that this time we are going to the left. So the phase shift is -1 because we're going 1 left. All right, so for the cosine graph, we have y equals a cosine bx minus c. A is 1, B is 1, and C is negative pi half. Oh, I put 1 left. I'm sorry, it's not -1. I'm thinking 1, like, I don't know, 1 space? I don't know. It's 2 spaces. But that's not left 1. It's minus pi halves. It's left pi halves, not left 1. Sorry about that. All right, so the phase shift is negative pi halves. So we'll fill in y equals a cosine b. Oh, why did I write that again? Let's just fill it in, okay? Y equals, we don't need the a. Cosine, we don't need the b, but we do need the c. X minus a negative pi halves. 2 negatives is a plus, so this is y equals cosine x plus pi halves. If we write it in terms of sine, the a is negative because it goes down instead of up first. It goes to its min, not its max first. For that, the only period we can see on this graph. The phase shift, the what else am I missing? The period is still 1, so b is 1. Period is still 2 pi, so b is 1. And the phase shift is 0. So this equation, I'm going to just move that up, would be y equals a sine bx minus c, but we don't need a b of 1, and we don't need a, oh, instead of c, ps, let me be consistent and put c equals 0. So c is the phase shift. I abbreviated it as ps on the graph so you could see it, but in our equation it is represented with a c. The only thing I need to replace is the a. So this is y equals negative sine x. So the same graph can be represented as y equals negative sine x or y equals cosine x plus pi halves. So notice the graph went one to the left, and sine A is negative. It's negative sine. When we went to the right, we had a positive sine x. But if you just identify your key components, the amplitude, max minus min divided by 2, or you can find it from the graph. Is there a reflection, yes or no? Does it go the typical way, or is it going the reverse way? If cosine was reflected, it would look like an upside down U instead of a right side up U. Identify the period, how long it takes for the graph to go through its sequence. If the period is 2 pi, then b is 1. Otherwise, you're going to solve period equals 2 pi divided by b, cross multiply and solve for b. All right, and then the phase shift is where does the graph begin the sequence. All right, it's supposed to begin, if there's no phase shift, it begins at the y-axis. If it begins to the right of the y-axis, it's a positive phase shift. If it begins to the left of the y-axis, it's a negative phase shift. And that's all of our parts. So I'm going to end this. Thanks for watching, and bye for now. Oh my, that's